Hello! Let's go through some basic definitions in linear algebra. So let's say we have this equation, a1 times x1 plus a2 times x2 plus a3 times x3 all the way up through an times xn, and that equals b. Here the x's are variables. They're only numbered because we don't really know how many there are, and we have that the a's and the number b are real numbers. Now this is a linear equation and the variables x1, x2, x3 all the way through xn. So traditionally we've seen linear equations in x and y. That would be when we had two variables. We've seen them in x, y, and z. That's when we have three variables, but we can have any number of variables. And what makes it linear is that we have the degree of each term is 1, except for possibly a constant term. So an example is 4.5x1 plus 6x2 minus 3.7x3 equals 2/3. That's an example of a linear equation. Of course, equivalent equations could be moving these variables around in any order because addition is commutative, or maybe adding the same number to both sides or multiplying both sides by some non-zero number. Those would all be examples of equivalent linear equations. So a collection of linear equations involving the same variables is called a system of equations. So we are only going to be talking about linear equations in this class. So we're going to be talking about a system of linear equations. We're taking one or more linear equations and we're considering them at the same time. A solution to a system is a solution to each equation at the same time. A solution to an equation being a substitution for each of the variables that makes a true mathematical statement. So if we have a solution to all the equations at the same time, it just means that I can substitute the values into each equation and get a true mathematical statement. And we'll do an example of this. And if I want to know what all the solutions are, I think about them as a set, and this is called the solution set. So let's do an example. So let's take x1 minus 2x2 equals 3, and x1 plus 3x2 equals 8. Each one of these equations by themselves is a linear equation in the variables x1 and x2, and taken together, if I consider those two equations, I need them to happen at the same time, I call this a system of linear equations. One solution would be 5, 1, meaning that x1 is 5 and x2 is 1. We list these sort of like coordinates because they really do mean something in terms of coordinates. And we think of 5 as being x1 and 1 as being x2. And we could go ahead and test this. This means that 5 minus 2 times 1 equals 3. Oh, that's a solution to the first linear equation. And 5 plus 3 times 1 does equal 8. That's a solution to the second equation. Since it's a solution to both at the same time, it is a solution to the system. So what does this mean graphically? So graphically, we visualize all the solutions to this first equation as a line. It's this line here. Each point on that line is a solution to that equation, and every solution to the equation is a point on that line. And here is roughly the graph of the equation x1 plus 3x2 equals 8. Every point on that line is a solution to the equation, and every solution to the equation is a point on that line. So notice I want to have a solution to both equations at the same time. That means it needs to be a point on both lines at the same time, and there is one of those, and it is the point 5, 1. This is going to carry over into more dimensions when we get into more variables, but we will always want to keep this in mind. So just a few more definitions for you. A system of linear equations is consistent if there is at least one solution in the solution set. So our previous example was consistent because 5, 1 was a solution. There's at least one solution to our system, and so it is consistent. Notice that sometimes I will shorten system of linear equations to just saying system, because system of linear equations gets very tedious. It doesn't mean that I'm saying something different. It just means that I'm shortening it. We say that a system is inconsistent if there are no solutions. Okay, so the last example was consistent. What about this system? X plus y equals 5, x plus y equals 17. That is an inconsistent system. That's because if x plus y equals 5, there is no way for x plus y to equal 17. So here's an inconsistent system. A lot of times it's not necessarily as obvious what an inconsistent system is, but in this case it was. If we wanted to graph this system, x plus y equals 5 is a line that looks like this. Right here, that point is 5, and this y value is 5. And x plus y equals 17. It's a line that looks like this. Right, this is 17, and this is 17. Okay, so notice those two lines don't cross at all. They are parallel. So there is no point that are on both lines at the same time. Okay, well, we're going to move on to more definitions and also getting into solving some systems of equations.